So welcome back to my channel. It's Kafka Skewer, the channel to talk about Kafka, and we will start to continue to talk about the Kafka optimization theorem. This is latency. Today we will talk about latency, how we can improve, what the best practice for Kafka, and what we can do to improve your Kafka. But remember, Kafka is designed to low latency, right? If you check the default and standard configuration for Kafka, here we have some examples in the beginning of the video, and I would like to comment some things here and perhaps can help you to how you can configure your Kafka environment, what you should be do, and if you want to use Kafka with low latency. If the priority of your clusters is low latency, okay, but let's understand a little bit what the use case. For example, IoT is a use case for low latency. Bank can be okay, not bonk, right? It's bank because they can know what's the transactions in real time, etc. So and the logs perhaps for the monitoring that need to know about the things that happen in real time. So latency is more like the things that we want to know in streamings in the real time. So what I mean, let me try to explain a little bit in the easy way that we can perhaps understood better. So let's think we have here a producer, right? In this side is my producer, and it will produce messages to Kafka. And I have now a consumer that will consume messages here in the other side. So the latency is the time. Let's talk this way. The messages come from producer to consumer more fast as possible as he can. So is the time the producer produce messages, commit these messages in Kafka, and is this message is available to consume messages, and so use these messages for whatever the consumer want. No, it depends of the rule that you do with the consumer, right? So this is the simple thing that we can understand a little bit about the latency, right? And so we have a different latencies, right? When you see is latency 50, latency 90, latency 99. Okay, so it's the three different latency normally, and in some cases 99.99, right? So this means we have 99% of the messages or the events. It's don't have any trouble. Use the maximum the system here. So 1% have a high latency. So which means low latency, it's good. So P99, if you in your charts you can see the P99, or in your dashboards you can see P99 on the high level, it's good because 99% of your cases in your events have a 99% use the in the maximum latency, in the I mean not the maximum latency but the low latency, right? I mean so this percent is very good to and to take a look. We can go in the blog post we opened the last time we talked about throughput. Let me open here. Okay. Oh, for some reason okay. We can open in this website here. So this is the Apache Kafka performance from the developer in the Confluent site. We can check the end-to-end latency and check how Confluent is. These guys did some couple of tests. It's a good one to check. So basically it's 200K messages per second with 200 megabytes, right? Which means it's 200,000 messages per second, right? And because you don't use the limit of the disk. If you remember, the disks have some limits, but they use just 200 here to not express, because this is not throughput test, it's a latency test. And if you check when the message is started, start to increase the latency ms, which means not increase the latency, but the usage of the message, which means the p99.9 of the latency it's higher, which means it's good to this Kafka. I mean, can consistently deliver low latency here. This is what this guy here means, which means Kafka can do this, right? You need to care about some dedicated things and some important things to configure it from the producer side and the consumer side. And that's I want to talk with you right now and explain a little bit here. Okay, so why producer? We put linger.ms equal 0 because it's as more fast as we can to send messages. I don't want to wait a little bit to form the batch size, right? When I want to throughput, we try to increase the linger.ms. But in that case, I don't want to increase the linger.ms. I want to send the message more fast as I can. So in the compression time, I don't use the compressed time. Why I don't use compressed time in the producer side? Because I want to use the CPU. I don't want to use the CPU is used a little bit to compress messages, or in the consumer side to decompress these messages, right? I want to use the CPU for produce and consume messages, and all the effort to only produce and consume messages. Don't need to do a lot of other things, right? And the acknowledge or acks here, we put 1, is the default is 1, right? In some case, you can put 0, for example, because you want to low latency. If you have a good infrastructure and you can guarantee that things works well, perhaps you can check if I mean, acknowledge equal 1. I want just to wait the leader to confirm the messages it's safe, and I can continue to produce messages, right? But in some case, perhaps 0 it's enough to you. But you need to care about and understand about this. In the consumer side, remember in the throughput we configure and try to put the fitmin bytes increase to more than 1. This is the default, right? But default here is 1 because we don't need to 0. We just, if you have 1 byte, I want to consume more fast as I can. In the throughput, I increase this number because I want more bytes to consume. In this case, I want to consume more fast. And the streaming sides, right? When you have the streamings configured like KCCO and other guys, we need to remember the streams have the consumer and producer together. So you need to care about this configuration here, and also a streaming config topology optimization, because the default streaming config is no optimization. So take a look to this configuration here, and perhaps you can improve your streamings and put more things, because the topology is optimization. You can put equal all, and you can reduce the reshuffles, right? And but take a look on this. What is the best thing for the brokers right now? Is the number of replica features. So is the number of the replica features I can increase it. This is the full value is 1, but you can increase more threads. Like, let's try to explain here a little bit, and perhaps you can understood better. Yeah, we have our Kafka here. So let's go and try to explain. So basically, Kafka have let's talk 2 brokers here and need to in backup. I mean, how the things works here. Kafka needs to replicate partitions between brokers, right? And this will just work like a consumer. So it's like Kafka have one consumer here and will consume messages from this partition here and produce it to this broker. This is a simple way to explain a little bit how the things work. But imagine you have 1,000 of partitions here, right? To be configured, to be consumed, but you have only one thread to consume all this partition, and they increase this number here, number replica features, to more than one, which means you now have more threads to consume all partitions that we have here to come to here. So perhaps you need to check. This is another thing that you need to care about. If you have a lot partition, let's talk, we have 100,000 partitions here on the brokers, this broker side here, and you need to replicate, and to have a replica equal 3, and need to replicate between 3 brokers only, right? It's a lot of partitions to replicate between 3 brokers, and you have a replica features, this parameter here, num replica features equal 1 only. Yeah, you can see your latency in a high level, and not, you do not work with low latency. I mean, perhaps you should be care about to know how much partitions I really need for my topics. You need to care about this because it's important to the balance between brokers, or I mean between how much partitions leader I have between brokers, how much total partitions and leaders and replicas, right, between all brokers I have. It's important to do and to configure this, and it's also it's very important, and perhaps in this case, in this specific scenario here with a lot of partitions, not increase the CPU and memory, I mean, for each brokers, so I can increase, you know, the number of replica features, I increase the number of network threads, number IO threads, you know, to give me more powerful between brokers to replicate the things. But one of the recommendations is add more broker nodes, right? And why I can want to add more broker nodes, because this way we can split all these partitions between more brokers, right? And I can split my workload between brokers, and this can reduce and decrease the high latency to low latency, and my P99 perhaps will increase. So this is something that you need to understood and think about if you want to optimization on the Kafka level and design your architecture in your Kafka. You need to understand a little bit about this. Another thing it is important here, it's one of common case that we can face when you use Kafka. Let's talk about, let's take this Kafka here. So I want my topic here, right? I have this topic here on Kafka, and it's very common that people want, and this is the recommendation for Kafka, right? Create a kind of CDC to put the messages on the specific from stable to topic, specific topic here, and so create your KSQL or streaming. You know, you can do how much you can, but I mean, try to do this. Create CDC. This is some common pipeline, or you can do, I mean, the SQL or something like that. Not only CDC, but I mean the connection to do a query on select on the database and come to specific topic, and so create a KSQL, and so split, create join and aggregation, create all the things, and also create the things here. It's end of the message. So I mean, what this mean, this pipeline here? Because we use a KSQL to do this, right? To do all the things, and so create here, and in the end of the day, I have my data prepared here to just do one thing. Just will consume a message and send it to external API, for example. Yeah, let's use this one, how, or external API. Or I can save these messages, I mean these events inside a database. This is the most common use case in the Kafka, and it's the best practice to do with Kafka. What is the thing that people make some mistakes is to not do the things this way, but create a Kafka here and a database here. Oh, sorry, and a database here. So I use, let's say, a consumer to consumer message to put here. I have one topic, right? And it's very common to do this way here. So let's pick up the API. And the guys want to consume messages, process messages in flight, right? Consult the API, and so go to another database here and try put the messages in another in this. I mean, this guy here do a lot of things, process messages, consult the API, consulting, and do some join aggregation between these two data, and also try to consume or put message in another topic, and or sometimes do the update in database, consult the API. I mean, this is wrong. Do not do this way. If you have some workload that, because I mean, it's very common. This guy probably cannot consume messages very fast. It's for sure. 99% of the case that I facing that we have issues with latency, lag, and the thing problems in Kafka, it's not because the consumer can consume messages in Kafka. I mean, guys, consume messages. If you are a consumer, the standard configuration for your Kafka consumer to consume messages to a specific topic is very fast. Kafka consumer can consume messages quickly. I mean, it's very, very fast. But the problem is, what do you do with your messages, the events that you consume, that you want to what do you want to do? This is the question here, and then is the time where we need to think and maybe reconfigure, redesign the architecture here, right? So this is we talk about latency. We talk about some configurations and indications, designing how you can use the P99. Sorry for my, I'm not the Picasso here. I'm not the best one, but I try to put some thinking. Perhaps we will remember because it's ridiculous, right? But yeah, it's funny, but like, I mean, I can send out the links. We talk about throughput, today latency. The idea is to talk about durability and availability, and cover all the things and talk about how we can decide the best option for our Kafka topic in the broker's side, consumer, producer, and streaming. Okay, thank you so much. See you later. Bye.